In this section, I'm going to step back from things as small as a bit and a byte and look at larger sizes like kilobytes, megabytes, and gigabytes that'll actually come up in day-to-day life. So a kilobyte, or KB, is about 1,000 bytes. So an email, a small email might be 2 kilobytes. A document that you're writing might be 50 or 100 kilobytes. In general, text, just plain text, is one of the most naturally compact types of data. So that doesn't really take a lot of space. The next size up is the megabyte. So a megabyte is about 1 million bytes, or I could think of it as about 1,000 kilobytes. MP3 audio, just as a very rough rule of thumb, you think of that as taking about a megabyte a minute. Or if you have a high quality digital camera, something that takes 10 or 20 megapixels, then those high quality images probably take something like 2 to 5 megabytes when you look at them on disk. So the next term up is the gigabyte. So a gigabyte is about 1 billion bytes, or we could think of it as about 1,000 megabytes. And this is probably the most common size that's going to come up for modern hardware. So you could think of 4,000 megabytes is equal to 4 gigabytes, or vice versa. So to switch between gigabytes and megabytes, they differ by a factor of 1,000. So for the megabyte figure, I could imagine like, well, basically I'm dropping the right 3 digits to go to gigabytes. So a computer today in 2012 might have maybe 4 gigabytes of RAM, be sort of a typical figure. A DVD disk, a single layer DVD disk, holds a little less than 5 gigabytes. Video data, although it varies quite a lot by how big it is and the resolution, but takes about 2 gigabytes per hour. A cheap flash drive that you might buy holds probably about 16 gigabytes today. And a cheap hard drive might hold 750 gigabytes, something like that. So the next term up is the terabyte, or TB, which is about 1,000 gigabytes, or you can think of it as about 1 trillion bytes. And we've just entered the time when you can buy a 1 terabyte or 2 terabyte hard drive. But other than that, it's not a term I see in use all that much. However, gigabyte used to be a rare term too. But then gradually, Moore's law and stuff getting more and more dense, now gigabyte's very common. So I expect terabytes time is coming. Just as long as I'm talking about terminology, I'll mention the word gigahertz. Gigahertz is not a measure of bytes, it's a measure of speed. So 1 gigahertz refers to 1 billion cycles per second. And so gigahertz, usually it'll come up when talking about how many cycles per second a CPU can do. So a CPU might be 1 gigahertz or 2 gigahertz. 2 gigahertz is sort of a common modern figure. So what I'd like to get out of this is that anyone today is comfortable doing sort of common forms of arithmetic with kilobytes, megabytes, and gigabytes to just sort of think about how big their data is and where it might fit. So I've got some problems here, some word problems involving megabytes and gigabytes. And as usual, I've got the show button here to look at the solution. Let's try the first one here. Alice has 600 megabytes of data. Bob has 700 megabytes of data. Will it all fit on Alice's 2 gigabyte thumb drive? So the first part of this is just adding the data up. So 600 megabytes plus 700 megabytes is 1,300 megabytes. And then we're left with sort of this units problem of like, oh, well, we've got a 2 gigabyte thumb drive. Is that going to fit? So you can think of 1,300 megabytes, as I mentioned before. These differ by a factor of 1,000. So to go to gigabytes, I sort of put the decimal point after the 3 digits. So 1,300 megabytes is the same as 1.3 gigabytes. So phrased that way, you can see that 1.3 gigabytes will fit on the 2 gigabyte thumb drive, no problem. Or we could have done it the other way. We could say, well, a 2 gigabyte thumb drive, how many megabytes is that? So that's going to be 2,000 megabytes. And so we can see that the 1,300 megabytes of data fits on the 2,000 megabyte thumb drive. All right, let's try another one of these. Alice has 100 small images, each of which is 500 kilobytes. How much space do they take overall? So there's 100 of these, so they're 500 kilobytes apiece. So I want to multiply by 100, which I think of as multiplying by 10 twice. So 500 times 10 is 5,000, and 5,000 times 10 is 50,000. So all 100 images is going to be 50,000 kilobytes, and then expressed in megabytes, I just take the left 2 digits here, that's going to be 50 megabytes, so 50 million bytes. So the images are fairly small, so 100 of them doesn't add up all that much. right, last problem. I'll say your ghost hunting group wants to record sound from a haunted Stanford classroom for 20 hours as MP3 audio files. How much data is that going to be expressed in gigabytes? So first I'll work out just how many minutes that's going to be. So 20 hours times 60 minutes in an hour is 1,200 minutes. So I want to have 1,200 minutes of data. And then the rule of thumb for MP3 audio is that it's about a megabyte per minute. So that's going to be 1,200 megabytes. Or expressed in gigabytes, that's going to be 1.2 gigabytes. So just as a detail, there's this thing I need to mention, which is I've talked about megabytes being, about 1,000 kilobytes, and I haven't really been more specific than that. In reality, there's these two different schemes. There's a scheme where each unit goes up by a factor of exactly 1,000, 1000, or there's a scheme where each unit goes up by a factor of 1,024, 1024. And that's just because inside the computer, doing things by power of 2 is sort of convenient. 1,024 is 2 to the 10th, and it's just sort of near to 1,000, so it's kind of a natural number to pick. So there's actually these two parallel schemes. When someone says megabyte or gigabyte, it's not really clear which scheme that they mean. Now for this class, I'm willing to just not care. I'll just figure like, well, whatever, it's about 1,000, and I'm not going to be more specific than that, and that's fine. That'll get us close enough. The error you might get is maybe 5 or 10%, so I can just live with that. If you care about that distinction, there is actually a set of terminology and rules that have been made up to define those terms exactly. And so if you're curious about that, you can. I had a little write-up down here about exactly what those terms mean. All right.